Hello, my name is Devin, and this is my BlueStamp engineering first milestone. I am building the ball tracking robot, which uses a Raspberry Pi and a Pi camera to track a ball and use the car to move towards the car and sort of track it. So the first step in this milestone is assembling the car, wiring all the components, and getting the car moving. Also, making sure all the components work, and that we can also detect images. And that is what you'll see today. These are the car and its components. This is the Raspberry Pi. These are the ultrasonic sensors. This is the breadboard. This is the H-bridge, which controls the motors. And this is the batteries. These are the motors. These are the wheels. And while demonstrating the movement of the car, I'll be lifting it up so when it goes forward and backwards, it does not drag along all these components, potentially disconnecting it. Here's the code behind what you just saw. This first part is just simply importing the necessary libraries. The next part is setting up which pins on the Raspberry Pi represent what in the motors, and this part forward is telling it to go forward. This one is telling it to go backwards by powering the backwards parts. Now this one, it's stopping, so it's all off. This one is turning, so now half of them are going forward, half of the motors are going backwards, and now this one's going left, so now the other half of the motors are going backwards and the other half are going forward now. And this is telling it to, and this is what actually makes it run by calling the function. Hello, so this is the code for the ultrasonic sensors. This section is simply setting it up. This is also setting it up as setting up trig as an output and set echo as an input. So this section is giving power to trig, and what that does is it sends like the ultrasonic signal to, and then once echo receives it, it finds the duration is the time when it ends to the time that it started, and then with that it figures that the distance is the duration times 17,150, and then it rounds up, and then we get our calculation. So now if I run the code, you see that this ultrasonic sensor here is what I'll be testing. I have it hovering a bit above the thing, and it registers at 5.56 centimeters, and now I have it pointed towards my monitor, which is pretty close in front of me. I'll put it, you can see it right there on the bottom of the screen, other than the camera. I run the code, and it registers as 3.3 centimeters, so you can see the difference as I changed the width. And the same code works for all the other ones. The only difference is the trig and echo, as I can't use the same pins. So this is the code for the Pi camera, which is the last component. So here's importing the libraries and what we'll be using. This is setting up and configuring the Pi camera, and this function actually starts it and opens a preview window for us. And this last part saves it. So once I click run, in a few seconds you will see a little window pop open that has a live streamed a live streamed, very slow rate, but live streamed video from the camera. And that is my project. My next step is to place all of my components onto my car and to start image tracking, so I can actually finish the core part of my project, which is the ball tracking robot. See you next time, and thank you for watching.